Hey guys, this is 5.3, the zeros of polynomial functions. So remember that the zero of a function is just the solution. If you were to graph the function, the zero would be where the graph crosses the x-axis. Okay, and I know we have found the zeros of polynomial functions when the polynomial looks like this, 5x squared minus 3x plus 8. If you only have x squared, an x, and a constant, we can use the quadratic formula, or we can factor it into two binomials. If we just have x without even an x squared, right? If it was just like f of x equals negative 3x plus 8, we could just solve for x, right? If it was an x squared, we can do the quadratic formula, or we can factor it. However, today we're going to work on x to the power of 3 and x to the power of 4 polynomials. Okay, we're going to use something called the remainder theorem, and we're going to also use synthetic division to find the zeros or the solutions of polynomial functions. Again, there's a lot of writing on this first page of notes. This is just an equation to represent something like this, right? You eventually get, at the end, you usually get to your constant. Before the constant, you have your term with an x. Before that, it will be x squared, and it can continue up and up and up, higher and higher, right? Today, the highest we will have is x to the fourth. Good? Coefficient, that's the word I was looking for. So we have the x and your coefficient. So first, we're going to reuse the remainder theorem to find the remainder when f of x is divided by x minus c. In this case, c would be our zero, right? Because x minus c, and I'll go over this again, but x minus c is our factor when we factored it into two binomials or more than two binomials, but c is our answer. Okay, those are kind of interchangeable, and we'll practice switching back and forth between them. Okay, so this says use the remainder theorem to find the remainder when f of x is divided by x minus c. The remainder theorem states that f of c is equal to the remainder of synthetic division by c. Okay, so you remember you've seen something like f of -1, right? One way that we can do that with the equation without using synthetic division is just to input that -1 for the value of x. So I'll do that right here. F of x equals x to the fourth plus 8x to the third plus 12x squared, which means that f of -1 would equal -1 to the fourth. I wanted to write a 4 right there. Plus 8 times the quantity -1 to the power of 3, because I'm just replacing that x with a -1, plus 12 times -1 squared. And we can just solve that. You can put it into your calculator as one big math problem. So you can just say -1, always use your parentheses if you're doing it this way, just to be safe. -1 to the fourth plus 8 times -1 to the third plus 12 times -1 squared. The answer we get is 5. So f of c, or f of -1, is equal to the remainder if we had taken x to the fourth plus 8x to the third plus 12x squared and used synthetic division and divided it by that c, by that -1. So that's the other way we're going to do it. We're going to get the same answer, okay? Synthetic division, what you want to do is you want to take that c, take what you are dividing your polynomial by, put it up here. You're going to put it in a box, and then you're going to take just the coefficients of each part. So this one is just a coefficient of 1, right? 1 x to the fourth. Then we have plus 8x to the third, so that's just going to be a positive 8. And then we have a plus 12x squared. The tricky part with synthetic division is that you need to make a place for each term, even if the term doesn't exist. So this is x to the fourth plus 8x to the third plus 12x squared, but we want to keep going. How many x's are there? There are 0 x's, and how many constants are there? There were 0 constants. Our constant was 0, we should say. Good. So I'm just going to put a 0 here and a 0 here to account for the end of the polynomial. Good? Now, what you're going to do is you're going to take, so remember, that's just that, that's that, that's that, and then those are filling in for the missing terms that are just 0. Now, your first number, you're just going to take it straight down. So 1 just remains 1 at the bottom. Take your bottom term, multiply it by that c. So 1 times -1 is a -1. Put it right up here below your next number. 8 minus 1 is 7. Take that 7, multiply it by the -1, you get a -7, put it below the 12. 12 minus 7 is 5, right? Already run out of colors. Good. 5 times -1 is a -5. 0 minus 5 is a -5. -5 times -1 is a +5. 0 combined with 5 is 5. So my remainder is 5, which is the same answer I got when I just put in the -1 for f. Sorry, for x. Good? So what I'm doing is I'm lining up each of the coefficients, and then I'm taking that first coefficient, bringing it straight down. That term I'm going to multiply by c, put it right here, and I'm going to I don't know if I made this clear. I'm combining 8 and -1. 8 plus -1 is 7. 7 times -1 is a -7. 12 combined with -7 is a 5, because 12 minus 7 is 5. 5 times -1 is a -5. 0 combined with -5 gives me -5. -5 times -1 is a +5. 5 combined with 0 is 5. So my remainder is 5. So we're finding the remainder of a synthetic division of this polynomial by -1. Okay? You would get the same answer if you divided the whole polynomial x to the 4th minus 8x to the 3rd plus 12x squared by x plus 1. Okay? After this, I'll show you how you would rewrite these into another equation or another polynomial. Excuse me. Okay. So here we're doing the exact same thing. F of x equals 5x squared minus 3x plus 8, and we're going to find f of 3. You're welcome to do it by just plugging in 3. So f of +3 is equal to 5 times 3 squared minus 3 times 3 plus 8. Put that into my calculator. 5 times 3 minus 3 times 3 plus 8 gives me, oh, sorry, I forgot to square that. Okay, let's redo it. 5 times 3 squared minus 3 times 3 plus 8 gives me 44. Good. So that was just plugging 3 in for x. Or synthetic division. Let's do another example of synthetic division. So I used -1 because -1 was my c value. Now my c value is 3. So I'm putting 3 right up here. And then I'm going to take each term, just the coefficient of each term. So I have a 5, a -3, and an 8, and those do descend, right? X squared, x constant. So I don't need to add any zeros anywhere. It's going to be a 5, a -3, make sure you keep the sign with the term, and a +8, right? That 5 just goes straight down. So our first number is going to be 5. Take that, multiply it by c. 5 times 3 is +15. -3 plus 15 is 12. 12 times 3, feel free to use your calculator. 12 times 3 is 36. Sorry, I think there was a glare on that. 36 and 8 is 44. So we get that same answer for the remainder because we have divided the whole polynomial by c. In this case, c was 3. In this case, c was -1. Good? Okay. Now they want us to use the factor theorem. This was the remainder theorem. The remainder theorem says instead of plugging in that number to make it equal to the remainder, I can use synthetic division to get that same remainder. Okay? Now, use the factor theorem to determine whether x minus c is a factor of f of x. Okay, x minus c is the factor but it's not the solution. I want you to think about, let's just think of an example, okay? To see the difference between what a factor is and what a solution is. So this is totally different polynomial, okay? Just going to use the polynomial x squared plus 8x minus 20. If I needed to factor this, right, it has to be set equal to 0. Now, here we're not seeing the set equal to 0, right? But in order to factor something, you need it set equal to 0. And then what do? You can do this method. You can do the quadratic formula, right? Here we would need two numbers that for here and for here, we need two numbers that multiply to equal -20 and that add to equal +8, right? Multiply to equal 20, sorry, -20, add to equal 8. So we could do -20 and 1. We could do +20 and -1. We could do 10 and 2, -2, or we could do -10 and 2. And you can keep going, right? But we see that 10 and -2 add to 8 and multiply to -20. So what our answers are x minus x plus 10, x minus 2, right? If I multiply this all out, if I FOIL it out, I get x squared minus 2x plus 10x minus 20, which when we combine like terms, we get x squared plus 8x minus 20. So it goes back to what we had before, right? So these are the factors of this polynomial. However, we need to find the zeros or the solutions of that polynomial, right? To find the solutions, this is set equal to 0. Now we take each of those factors, x plus 10 and x minus 2, set each of them equal to 0. So now I have x plus 10 is 0. Solve it by moving the 10, getting the x alone. Subtract 10 from both sides, and we get x is -10. For this one, x minus 2, set it equal to 0. Add 2 to both sides, and we get the answer x equals 2. What do those mean? Those mean that if I put that if I put that -10 back into the original equation, it will equal 0. It will be true. So that is a solution because it makes it true. It has an equal sign and it makes it true. Let's just test it. So we had x squared plus 8 times x minus 20, and my x is -10. -10 times 2 is 100. Adding 8 times -10 is -80 minus 20. 100 minus 80 minus 20 is equal to 0, right? Again, we can test it with the 2. We have x squared. So we have x squared plus 8 times x minus 20. And that was a 2, positive 2. 2 squared is 4. 8 times 2 is 16. 4 plus 16 minus 20 is also 0. Okay, so those are the solutions or the zeros. These are the factors. So again, These are the factors. I just rewrote them down here. Factors. These are the zeros or the solutions. Do you see any relationship between the factors and the zeros? The relationship I want you to see between the zeros and the factors is that when I have my zero, x equals -10, if I put it into x minus c as the c, x equals -10, x minus c, when c is that -10, x minus -10, x plus 10 is my factor, okay? Again, x equals 2, using the formula x minus c, where 2 is the c, x minus 2 is my factor, okay? So these are interchangeable. If you have a 0 and you want to make it a factor, you subtract it from x. If you have the factor, you need to change that sign, okay? X minus 2 is the factor, so this 0 is going to be positive 2. X plus 10 is the factor, so the 0 is going to be the change sign of that part. So we change the sign from -2 to +2, from +10 to -10, because we are subtracting our 0 from x. Okay? We are subtracting the answer from x. That is the relationship between factors and zeros. Good? So that was just a side note. So x minus c is x plus 9. So our c, let's practice. C is -9 in this case. Our 0 is -9 because we're subtracting our 0 from x. Good? Okay, using the factor theorem to determine whether x minus c is a factor of f of x. The factor theorem is this, we're going to use the same synthetic division, but if it is a factor, the 0 will produce a remainder of 0, okay? If this is an actual 0 or an actual solution, if it is a factor, it will produce a remainder of 0. This produced a remainder of 44, this produced a remainder of 5, okay? Is it a factor? Is the remainder 0 when I do synthetic division, okay? So my first step is to change the factor to a 0. If the factor is x plus 9, the 0 is -9. Good? Then I take that 0 and I do synthetic division of that polynomial. And if the remainder is exactly 0, we can say that it is a factor, okay? So I have x to the third plus 7x squared minus 16x plus 18. That means I'm going to use 1 for x cubed, 7 for x squared, -16 for x, and 18 for the constant. I don't have any gaps, so I don't need to include any zeros. Remember, take that first one, bring it straight down. Now, 1, multiply it by c. 1 times -9 is -9. 7 combined with -9 is a -2. -2 times -9 is a positive 18. -16 combined with positive 18 is a 2. 2 times -9 is -18. 18 minus 18 is 0. So if the remainder is 0, here the remainder was 44, here the remainder was 5. If the remainder is 0, it is a factor. So yes. You can also check it by just plugging in -9, right? So let's take all of these and just replace x with -9, okay? So -9 cubed plus 7 times -9 squared minus 16 times -9. I'm going to move it down. Oh no, only one more. Plus 18. Does that give me 0? Minus, no, that's a negative sign. Minus 16 times negative 9 plus 18. And it gives me the answer of 0, so that is a 0, okay? I don't want you, like, I just proved it, but I don't want you to use that method. I would like you to use this method because this is what we're going to use for all the rest of this lecture. Good? Okay, next one is we have the polynomial f of x equals x cubed plus 3x squared minus 8x plus 10, and our factor is x minus 5, okay? If our factor is x minus 5, that means that c is being subtracted from x, so we're going to change the sign, right? C is being subtracted from x, so the original c must have been a positive 5. Then we're going to take each leading coefficient, each coefficient of each of the terms of the polynomial. X to the third is the coefficient 1. 3x squared is a coefficient of positive 3. Negative 8x is a coefficient of negative 8. And then 10. Good. Take that 1, bring it straight down. Now multiply by c. 1 times 5 is 5. Combine 3 and 5 to get 8. 8 times 5 is 40. 40 minus 8 is 32. 32 times 5, 160. So that's not going to give us a 0, right? Going to give us 170. So that is not a factor. You can also put that positive 5 in here. 5 cubed plus 3 times 5 squared minus 8 times 5 plus 10 will not give me 0. So that is not a factor of the polynomial. Good? Okay. For the linear factorization theorem, any polynomial function where those are complex roots, honestly, we don't really need that. Okay. To find all the zeros of a polynomial, these are polynomials, right? If you can see how to factor the polynomial, then do so. We might be able to factor something like this, right? If the degree is 2, you can use the quadratic formula because you could not factor it, right? Then, if you are given a root, use synthetic division to test that 0 gives you a remainder, that solution gives you a remainder of 0, and that will be an actual 0, okay? Do not change the sign of a root, only change if given a factor. So that's what we just went over. If you have the factor, you change the sign. If you're just given x equals negative 9, don't change the sign because you're not being given a factor, you're being given the actual 0, okay? Once you find the first rational 0, the resulting answer from synthetic division will give you the next polynomial, so you can continue checking for rational zeros until you get to a degree of 2. Once you get to the degree of 2, you can either factor it into 2 different binomials or use the quadratic formula, okay? So number 7, given a root of the polynomial, given a 0, of the polynomial function, use it to find all the zeros of the function. Here we have f of x equals 3x cubed minus 17x squared plus 18x plus 8. And the 0 we are given, not the factor, notice, the 0 is x equals 2. So x equals 2, if it were a factor, it would be x minus 2, right? Because the factor is always x minus that root. So my root is positive 2. So I just put that 2 right here. And I'm going to use synthetic division. So I've got 3 as my first term, 3x cubed, a negative 17 for my x squared, a positive 18 for my x, and an 8 for my constant. Again, make sure it's in ascending order. X to the power of 0, x to the power of 1, x to the power of 2, x to the power of 3. okay? Now, take that 3 straight down. Now start multiplying. 3 times 2 is 6. Negative 17 plus 6 is just a negative 11. Negative 11 times 2 is going to be negative 22. 18, 19, 20, 21, 22. So that's a difference of 4. So that'll be a negative 4. Negative 4 times 2 is a negative 8. That's a 0. So that is our remainder, which means that that is a 0. But that wasn't the question. They already gave us that it's a 0, right? Okay. What do we do next? We know that that's a 0. We synthetically divided it. We did division, right? Now what do we do? Now I need you to take these 3 numbers and make a new polynomial from them, okay? What we do is we call that first number, even if it's a 0, okay, it's in the first spot, that first number is our constant. The number in front of it is our x to the power of 1, so negative 11x, and then here we've got 3, and we just go up 1, right? Constant x squared. If we had a number in front of it, we would be x to the third, okay? We would just keep going. Right now we have 3x squared minus 11x minus 4. Now you are welcome to just look at 3x squared minus 11x minus 4 and see if you can factor it, or go straight to the quadratic formula if you prefer. But I'm just going to look at it. I'm going to say, okay, it has to multiply to equal a times c. A times c is negative 12, so it should multiply to negative 12, and it should add to a negative 11. And probably do that, right? Negative 12 times 1 will give me negative 12, and negative 12 plus 1 will give me negative 11. So this is actually, right, because this is not just x squared is 3x squared. We then change that to 3x squared. Our b becomes 2 different terms, and our c stays the same. So negative 11x becomes x minus 12x minus 4. And you're welcome to switch that order too. You can say 3x squared minus 12x plus x minus 4, or 3x squared plus x minus 12x minus 4, whatever you would like. Now we're going to factor by grouping. What is a common factor between 3x squared and x? It's just the letter x. 3x squared divided by x gives me 3x, and then x divided by x gives me a 1. And then over here we have negative 12x plus 4. I need to divide it by a negative, so I'm going to put a minus right here. 12x and 4, I can divide them both by a negative 4. So that gives me negative 12x divided by negative 4 gives me a positive 3x. And then negative 4 divided by negative 4 gives me a positive 1. And then those are my common factors, 3x plus 1. And what's left? X minus 4. So those are my factors. I still need to find the zeros based on the factors. How do you find a 0 after you found the factor? You set that factor equal to 0. So 3x plus 1 equals 0. Subtract 1 from both sides, you get 3x equals negative 1. Divide by 3, you get x equals negative 1/3. Good? This side will be a little bit easier. X minus 4, set it equal to 0. Add 4 to both sides, and you get x equals 4. Now, the way we're going to write it is find all the zeros of the functions. All the zeros are x equals, start your bracket, and then go from your smallest number to your biggest number, okay? My smallest number is negative 1/3, and we're just making a list. And then it is, don't leave out the one they gave you. So they gave you that one, included in your answer, okay? Negative 1/3, they gave us 2, and then 4. And then you close those brackets. Those are the zeros of this polynomial function. If you were to go put in negative 1/3 for x, the answer would be 0. If you put in 2 for x, your answer would be 0. If you put in 4 for x, the answer to all of this would be 0. That's what we're doing, okay? All right, let's move on to number 8. That's a little bit harder. We have x to the 4th. So with x to the 3rd, all you need to do is do synthetic division once, and then you have a nice trinomial. We know what to do with trinomials. We can either factor them by hand, or we can use the quadratic formula. But here with x to the fourth, 7, 8, 9, just want to make sure. Here you are going to factor, right? You're going to use synthetic division for x equals -1, and you're still going to have x to the third. So it's quite a bit harder, in my opinion. But let's start with the synthetic division part. We have x equals -1 as the 0. So I come over here, -1, and then 1x to the fourth means that this number is 1. 4x to the third means this one's a 4. Negative x squared is a -11. Negative 26x means it's a -26, or sorry, minus 26x. And then negative minus 12 means it's going to be a -12. Send that one straight down. Multiply my answer by the 0. 1 times -1 is a -1. 4 minus 1 is 3. 3 times -1 is a -3. -11 times a -3, or sorry, -11 minus 3 is a -14. Times a negative. Negative times a negative is a positive. So now I have a -26 plus 14 is -12. Multiply that by -1, I get a positive 12, and my remainder is 0. So we have ensured that that is really a factor, and now we have a new polynomial, okay? Our new polynomial is, I like to start at the back. So -12 is my constant, -14, x to the first, +3, x squared, and then 1x cubed, okay? What do we do now that we have an x cubed, right? We can't just factor it the way that we have been factoring things in this course previously. What you want to do is, well, first you can look at it. You could say x to the third plus 3x squared minus 14x minus 12. Can I factor by grouping? Can I factor anything out of the front and out of the back that would give me a situation like this, right? Where the binomials would match and I could factor out a binomial. In this case, we cannot. Here, you could factor out an x squared, but that would still just be x plus 3 and -14x and -12. Anything you can factor out of them wouldn't give you an x plus 3 as your answer. Okay, so there's no way to do that. What you need to do now is find other zeros. We're kind of guessing and checking, but there is one guide for this, for which numbers you should be guessing and checking with, okay? The guide for that is, so our guide for finding these zeros, the rest of the zeros, including this one, is a formula we call P over Q with, you call your constant being P and your leading coefficient being your Q, okay? Not just -12 over 1 in this case, but all factors, all possible factors of -12 over all possible factors of Q. All possible factors of P over all possible factors of Q. Q is just 1, but -12, the factors of -12 are plus or minus 12, plus or minus 6, what else? Plus or minus 4, plus or minus 3, plus or minus 2, and plus or minus 1. Right? So our possible real zeros, rational zeros of this equation are 1, -1, 2, -2, 3, -3, 4, -4, 6, -6, 12, -12. Okay? And we're kind of just going to guess. All right? We've already got -1. I can go on to +1. So let's see if +1 is a factor of x cubed plus 3x squared minus 14x minus 12. Okay? X cubed plus 3x squared minus 14x minus 12. And we're going to do We did -1, so we're going to do 1. Got a 1. So we're not using this exact 1, right? Because we already factored out. We already factored out the -1. So we're going to use this equation. X cubed plus 3x minus 14x minus 12. So it's a 1, it's a 3, it's a -14, and it's a -12. The 1 comes straight down. 1 times 1 is 1. 3 and 1 is 4. 4 times 1 is 4. That's -10 times 1 is -10. And that does not give me a 0, right? Okay, so we tried +1. We already used -1. You could use -1 again if you want, but we're just going to go, I'm just going to go on to 2. Well, we'll try -1. -1, same numbers, 1, 3, -14, -12. So I just have that same top row. Bring that 1 straight down. 1 times -1 is -1. 3 minus 1 is 2. 2 times -1 is -2. -14 minus 2 is a -16 times -1 is a +16. That didn't work either, okay? Even though -1 was already a factor of this one, you can try it again, okay? Because that's easier than going on to +2 or -2. Now, though, we do need to go on to +2. So we've got 2, same numbers, 1, 3, -14, -12. 1 comes straight down. 1 times 2 is 2. 3 and 2 is 5. 5 times 2 is 10. -14 plus 10 is -4. -4 and 2 is a -8. So that's not it. Oh, sorry, you couldn't even see that. All right, I'm going to recopy it. So it wasn't 2. I'm going to go to -2, 1, 3, -14, -12. So we've tried all of these. We've tried the +2. That 1's going to come straight down. 1 times -2 is -2. 3 minus 2 is 1. 1 times -2 is -2. So now that's -16. -16 times -2, -32. And that's not giving me a 0, right? So we're searching all of these to find a 0. So it was neither of the 2's. We'll go on to +3. Same numbers, 1, 3, -14, 12. But instead of -2, we're going to do a +3. The 1 comes straight down. 1 times 3 is 3. 3 and 3 is 6, so those don't cancel. 6 times 3 is 18. -14 plus 18 is just 4. 4 times 3 is 12, and that gives us a remainder of 0. So we can say that 3 is a 0 of x squared plus 4x cubed minus 11x squared minus 26x minus 12. So it's x equals -1, x equals 3. And we're going to need to find some more, right? Because we still have a trinomial here. How do we write it? 4 is my constant, it's a positive. 6 is my x, it's a positive. And then we just have x squared. So now I'm looking at x squared plus 4x, 6x plus 4. Can I factor this into two binomials? Is there anything that adds to 4, or sorry, that multiplies to 4 but adds to 6? There's not. So at this point, I need to use the quadratic formula. The quadratic formula is x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. I'm going to go through this part quickly because we've definitely done this a lot in this class already, okay? X equals -6 plus or minus the square root of 6 squared. If this was a negative, you'd need to be careful with the negatives, but basically 6 squared is 36, right? Minus 4 times a, which is 1, times c, which is 4, over 2 times 1. Good? So x equals -6 plus or minus, change colors, it's getting confusing. X equals -6 plus or minus the square root of 36 minus 16. 36 minus 16 is just 20, right? Over 2. Now take that square root of 20. What does 20 become? 4 times 5. What is 4? 4 is, the square root of 4 is 2. 4 is 2 times 2, so that becomes 2 square root of 5. Okay? So x equals -6 plus or minus 2 square root of 5 over 2. Now I'm going to divide -6 by 2 and 2 square root of 5 by 2. X equals -6 halves plus or minus 2 square root of 5 over 2. That's going to become -6 divided by 2 is just a -3. And then plus or minus 2 square root of 5 divided by 2, square root of 5. Okay? So, and it's important that those are two different answers. So we're saying x equals -3 plus square root of 5, -3 minus square root of 5. And what were our other answers? -1 and 3. Again, if we had to write it, x equals brackets. I'm going to say -3 minus the square root of 5, -3 plus the square root of 5, -1, which is the one they gave us, and 3, which is the other one we found. Oops. And that's our answer for number 8. Good. I know it's a lot of work. Number 9. F of x equals -x to the 4th plus 9x cubed minus 48x squared plus 78x plus 36. And the 0 they gave us is x equals 4. I'm going to take that 4. No need to change the sign, right? Because they didn't give us a factor. They gave us the 0 of it. -x to the 4th is just a -1. 9x to the 3rd is a +9. -48x squared is -48. 78 and 136. Good. The -1 comes straight down. And then we multiply by 4. -1 times 4 is a -4. 9 minus 4 is just 5. 5 times 4 is a -20. -4, oh, +20 because there's no negatives. 5 times, a positive times a positive is a positive. -48 plus 20 is just -28. -28 times 4 is -112. Plus 78. We're going to combine it with 78 and we get -34. -34 times 4. What do we want it to be equal to? We want it to be equal to -136. If it's equal to -136, that means it's a 0 as a remainder. So that was a 0 of the polynomial function, a solution of the polynomial function. Now we have -1x to the 3rd, 5x plus 5x squared minus 28x minus 34. Good. So we put that back into its polynomial form. And now again, we need to find another factor of it. Look at -x cubed plus 5x squared minus 28x minus 34. Make sure there's nothing you can factor out or factor by grouping, because that will make it easier. If there's not, do p over q, which remember, it's -34, all of its factors, over -1. So the factors of -34 are plus or minus 34. I guess I should have gone in ascending order instead of descending. So 34 divided by 2 is 17. plus or minus 17 plus or minus 2 plus or minus 1. Good. Now, you may be noticing that 4 isn't on this list, right? That's because these are factors of this equation, and right now we're looking at this equation. It's a different polynomial, okay? So our only options are 34, 17, 2, and 1, but we have to check both the positive and the negative, okay? So we're going to use -1, +5, -28, and -34. And let's just start with a +1 because that sounds simplest. 1, and then my terms are -1, +5, -28, and -34. The -1 comes straight down. -1 times 1 is -1. That becomes 4 times 1 is 4. -28 plus 4 is a -24 times 1 is -24. And that does not give me a remainder of 0, right? All right, we'll go to the next one, -1. Same numbers, -1, 5, -28, -34. Take that -1, bring it straight down. -1 times -1 is a +1. 5 and 1 is 6. 6 times -1 is a -6. -28 minus 6. -28 minus 6 is -34. -34 times -1 is a +34, and that does leave us with a remainder of 0, so we found another 0. Another one of the zeros besides 4 is -1. So let's add that. X equals 4, x equals -1. And what are we left with? We have -x squared plus 6x minus 34. Can we factor this? Are there any numbers that can multiply to equal -34 but add to equal 6? Well, we saw up here that the factors of 34 are 34, 1, 17, and 2, right? 17 minus 2 isn't going to give me a 6. And 34 minus 1 isn't going to give me a 6, so I'm going to put it into the quadratic equation. Quadratic equation is x equals -b, so -6 plus or minus the square root of 6 squared minus 4 times a, which is a -1, times c, which is a -34, over 2 times -1. Good. So that's -6 plus or minus the square root of, and you can just put it into your calculator, 6 squared minus 4 times -1 times -34 gives me -100. And then 2 times -1 is a -2. Good? So that's x equals -6 plus or minus, what's the square root of -100? It's 10i, right? Divided by -2, and then we're just going to divide out the -2. -6 divided by -2 is a +3 plus or minus. 10 divided by -2 is going to be a -5i, but we've already got the plus or minus. So plus -5 is just a -5, and minus -5 is just a +5, so I'm just going to call that 3 plus or minus 5i, and that's our last x value. X equals 3 plus or minus 5i for 9. Good? All right, we've got 10, 11, 12, 13. A few more. Again, it says solve the polynomial equation. Given one factor, use synthetic division to find the other roots. So we've got -x cubed plus 5x squared minus 17x plus 13 equals 0. But they gave us a factor instead of a root. Now that we have a factor, the root is the opposite of that term, right? -1 becomes a +1. Good? All right, so we'll put the 1 here. Let's see if we can fit it all. -1 plus 5 minus 17 plus 13. -1 comes straight down. -1 times 1 is a -1. 5 minus 1 is 4. 4 times 1 is 4. 17 minus 4 is, sorry, -17 plus 4 is a -13. -13 times 1 is a -13, so that's a 0. And what we've got is, oh good, -x squared plus 4x minus 13. Is there anything that multiplies to -13 but adds to 4? There's not. So we're going to put it into a quadratic equation. You can either put -x squared plus 4x minus 13 or x squared minus 4x plus 13 if you prefer. But basically we've got x equals -4 plus or minus the square root of 4 squared minus 4 times -13 times -1 over 2 times -1, -4 plus or minus 16, right? 4 squared minus 4 times -13 times -1, -36 divided by -2. The square root of -36 is just 6i, right? So it's x equals -4 plus or minus 6i over -2. -4 divided by -2 is just 2 plus or minus 6 divided by -2 is 3i. And again, it was a -3i, but since that's a plus or minus in front of it, that kind of cancels it out. So our last answers are x is x. Our factor was x minus 1, so our 0 is x equals 1, and x equals 2 plus 3i, and x equals 2 minus 3i. Or 1, 2 minus 3i, 2 plus 3i. Close the brackets. Good? All right, last page. Number 11, x cubed plus 9x squared plus 36x plus 24. When we have the factor x plus 2. X plus 2 means our 0 is actually -2. And then we've got 1, 9, 26, 24. 1 comes straight down. 1 times -2 is a -2. 9, 8, 7. 7 times -2 is -14. 6 minus 4 is 2. 2 minus 1 is 1, right? So 26 minus 14 is 12. 12 times -2 is a -24. 24 minus 24 is 0. So that's a 0. And then we've got 1x squared plus 7x plus 12. Now let's think about, can we factor this? Are there any numbers that multiply to equal 12 and add to equal 7? I think it's 3 and 4, right? So this will just be x plus 3, x plus 4. Remember, set it equal to 0. That means that x is 3, -3, x is -4, and x is -2, right? Because the other one they gave us was x plus 2. Subtract 2 from both sides, get x equals -2. Subtract 3 from both sides, get x is -3. Subtract 4 from both sides, get x equals -4. Those are our 3 answers for number 11. Number 12, we have x to the 4th minus 3x cubed plus 2x squared plus 16x minus 16 equals 0. And the value they gave us is x equals -2, the 0. So we'll put -2 up here. We've got a 1, a -3, a 2, a 16, and a -16. The 1 comes straight down. 1 times -2 is -2. -3 combined with -2 is a -5. -5 times -2 is 10. 10 times 2 is 12. 12 times negative 2 is negative 24. Negative 24 plus 16. Negative 8. Negative 8 times negative 2 is a positive 16. Negative 16 and positive 16 is 0, so that is a factor. We've still got 4 terms, so we've got x cubed minus 5x squared plus 12x minus 8. Good. And we've got to find another 0, right? Can I group these and divide them? I cannot. So we want to do P over Q. P over Q. Thankfully, Q is still just 1. P is negative 8, so it could be plus or minus 8, plus or minus 4, plus or minus 2, and plus or minus 1. Now, I know that I said we already found the negative 2, but that's not actually a factor of this, right? This is a totally new one. So it might be negative 2 again. Let's start with just positive 1 and hope that it works. Again, I'm using 1, negative 5, positive 12, negative 8. I'm not using the same numbers I did in the first time. 1 comes straight down. 1 times 1 is 1. Negative 5 plus 1 is negative 4. Negative 4 times 1 is negative 4. 12 minus 4 is just 8. 8 times 1 is 8. Yay! So x equals negative 2. I'm going to add x equals 1, right? Because I found another factor. And then I'm going to take this as x squared minus 4x plus 8. Good. Now, are there any numbers that I can multiply to equal 8 and add to equal 4? It's negative 4. It seems like there should be, right? But really it's 8 and 1, negative 8 and negative 1, negative 4 and negative 2, or positive 4 and positive 2. So nothing really works. We do have to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. 4 plus or minus 16 minus, what's 4 times 8? 32, because those were both positives, and then what's a minus sign? So it's negative 32 over 2. X equals 4 plus or minus the square root of 16 minus 32 is just negative 16. Divided by 2. The square root of negative 16 is just going to be 4i, right? Divided by 2. And then you take both 4s and divide them by 2. 4 divided by 2 is 2. 4i divided by 2 is 2i. So for this one, we've got x equals negative 2, x equals 1, and we're going to add x equals 2 plus 2i, x equals 2 minus 2i. Excuse me. Good. All right, 13 is our last one. I'm just going to show you because it is a little bit tricky. So we've got x to the fourth minus 8x to the third plus 7x squared plus 42x plus 26. And we've got negative 1. So negative 1, 1 minus 8 plus 7 plus 42 plus 26. Oh, I didn't need those pluses. The 1 goes straight down. 1 times negative 1 is negative 1. Negative 8 minus 1 is negative 9. Negative 9 times negative 1 is a positive 9. 9 and 17 is 16. So that's now a negative 16 when we multiply it by negative 1. 42 minus 16 is 26. 26 times negative 1 is a negative 26, so that is a factor. Now we have 1x to the third minus 9x squared plus 16x plus 26. All right. Does anything factor? No, so we have to start inputting what could be a 0, right? So we're going to do P over Q. So we're going to do 26 over 1, right? So that could be 26. 26 divided by 2 is 13. 2 and 1. And remember, it's either positive or negative. All over 1. Okay. So we've already done -1, but we really only did -1 to this one. We haven't done -1 to this one. So you can start with -1 again. But don't use those same numbers. Don't use 1, -8, 7, 42, and 26. Use 1, -9, 16, and 26. Use the bottom of the last division that you did. 1 times -1 is a -1. -9 minus 1 is a -10. -10 times a -1 is a +10. 16 and 10 is 26. 26 times -1 is a -26. And we found another factor. Good. So now we've got x squared minus 10x plus 26 as our polynomial. And we're going to factor it if we can. Is there any way to factor this? Anything that multiplies to equal 26 but adds to -10. There's not. So we'll just do quadratic formula. X equals -b plus or minus the square root of b squared minus 4 times a times c plus or minus 10 squared minus 4 times 26 -4 over 2. The square root of -4 is just 2i over 2. And then we're going to just divide both of those parts by 2. 10 divided by 2 is 5. And then 2i divided by 2 is I. So we have 5 plus or minus I. So our answers are x equals -1, x equals -1. You don't need to write it twice. It just is a fact that we found so that we could keep finding the rest of the answers, plus or minus I. Nope, sorry. X equals 5 plus I. X equals 5 minus I. All right, guys, and that is how you find the zeros of polynomial functions. Thank you for watching and have a great day.